we want to solve some right triangles because right triangles are relatively easier to solve. They are special because of a right angle in the right triangle. So first of all, let us restrict our attention to acute angles. I want to talk about trigonometric functions at acute angles. That is how we're going to evaluate trig functions at an acute angle. So here we look at this theta. So you see the theta as given in the standard position. So this is standard position that is initial side, right, coincide with the positive x-axis. And the vertex of the angle is at the origin, right? So that's a quick review of theta. But this theta is an acute angle. And as you can see, in order to decide the trigonometric function values at theta, we need to know a point at the terminal side of theta. So here is the point, this P. P clearly is acute, so this terminal side is in the first quadrant. And therefore, XY coordinates are positive. So we can quickly label this. So this is a X value, Y value of the P, the point P. So they're both positive. By definition, for the trigonometric function values, we can quickly write sine of theta is y over r, right? So as you can see, we have a right triangle here. So r is the hypotenuse of the right triangle. So sine theta, by definition of sine, it is the y over r. R is always positive. So cosine theta, for the same given theta, is x over r. R is positive. But since we know x and y are both positive, therefore sine value and cosine value are positive. So it's not difficult to see that all the trigonometric function values are positive for an acute angle theta. So if we write tangent theta is y over x. Since both x, y values are positive, right? It's a first quadrant, the angle in the first quadrant. So tangent value at theta is also positive. Okay, so now let's try to understand the definition using this right triangle. For the theta here, for this theta, y is opposite, the side opposite to theta. R is hypotenuse. So the sine value is the side opposite to theta over hypotenuse. And cosine theta. Cosine theta, we can, by definition, is x over r. X, you see this x, it is the side adjacent to theta. So cosine value at theta is x, the side that is adjacent to theta, over hypotenuse. And tangent theta, tangent is y over x, right? So y over x. You see, y is the side opposite theta over the side adjacent to theta. So that is our tangent value at theta. So using this way for any acute angle, we can give this definition of sine, cosine, tangent at an acute angle. So yes, the tangent, sine, cosine, tangent, right? We just reviewed according to definition. For acute angle, it's simply the side opposite theta over hypotenuse. That is sine value at theta. Cosine value at theta is the side adjacent to theta over hypotenuse. And tangent value at theta is the side opposite theta over the side adjacent to theta. So after we know how to calculate sine, cosine, tangent, and then for cosecant, secant, and cotangent, the other three will be relatively easy because we know reciprocal, the definition, right? For cosecant is r over y, which is really the reciprocal of sine value at theta. Yeah. So cosecant theta is hypotenuse over the side opposite theta. And secant theta is r over x, which is the hypotenuse over adjacent side. And cotangent theta is x over y, which is adjacent side over opposite side. So all 6 trigonometric function values can be determined for an acute angle. And don't forget, here, x, y, r are all positive. So all 6 trigonometric function values are positive for an acute angle. Yeah, simply because the acute angle is in the first quadrant. If the angle is placed at the standard position. So let's look at a very special angle, a 30-degree angle. So I'm going to show you the picture. Yeah, so we look at, let's just look at 30-degree angle. So in this figure, we see an equilateral triangle. The equilateral triangle, as you can see, it's a 2 and 2, right? And 2, 2, 2, 2. Each side is a 2. That also each angle is the same. Degree measure is 60. You see, 60 and 60. Yeah. So we see equilateral triangle, but we split this triangle using this height. Okay, so if you divide this equilateral triangle into two parts, let's say along the height. So this is the line, right? This horizontal line, and which is perpendicular to this base. Okay, so then we can see that, and the 60-degree angle will become a 30-30. So now we want to focus at a right triangle, which is this portion. This right triangle, we have an acute angle, which is a 30-degree angle. So for the 30-degree angle, can we find the 6 trigonometric function values? So let's just look at this right triangle. This is 1, right? The other side is 1. So this is 1, and the hypotenuse is 2. And the base, because it's a right triangle, we can calculate so because in the right triangle, you have one leg is 1, hypotenuse is 2. Then what is the other leg? The other leg is hypotenuse square minus this leg square, and then this is the x we want to find, right? What is the x? So x squared must be the hypotenuse squared minus 1 squared. So that means x squared is 4 minus 1, which is 3. Therefore, x is square root of 3. So we found that x is square root of 3. So that means we're ready to find the trigonometric function values for the 30-degree angle, because we have x value, we have y value, and we have r value, and then we're ready to find sine, cosine, tangent, etc. Okay, let's go ahead and find sine theta, which is sine 30 degree. The theta is 30 degree. Now, it is y over r. Y is 1. So r is 2. So sine 30 is 1/2. Now, cosine 30. Cosine 30 degree is x over r. X is the square root of 3 over hypotenuse, which is 2. And tangent 30. Tangent 30 degree is y over x. Y, remember y is the opposite side. The side opposite to 30 over x, the side adjacent to 30 degree, which is square root of 3. Now we continue. So we can do the cosecant. Cosecant 30 degree, according to the definition, r over y, which is the hypotenuse over the side opposite the 30-degree angle, which is 1. So 2 over 1 is 2. So continue, we do the secant 30-degree angle. Secant is r over x, which is hypotenuse over the side adjacent to the 30-degree angle, square root of 3. So yes, the answer is 2 over square root of 3. If you do not like the irrational number in the denominator, what do we do? we can rationalize the denominator. That is, we multiply denominator and numerator by square root of 3, respectively. So this way we get a number. So so the numerator will become 2 times the square root of 3. Denominator, you multiply square root of 3 by square root of 3, you get 3. So you see, the answer is a fraction, and the denominator is no longer irrational. Yeah, so one more value. So that is cotangent. Cotangent at 30-degree angle. So I'm going to write cotangent 30 degree is equal to x over y. X, you see, we look at the 30-degree angle again, x over y. So the side adjacent to 30 over the side opposite 30-degree angle. So which is 1. So the cotangent 30 degree is equal to square root of 3. So now we got all 6 trigonometric function values at 30-degree angle. And also, if you give 1 second to these values, and it's not surprising, right? The sine, which is half, and cosecant is the reciprocal of sine. That's a 2. And if you look at cosine, which is a half of square root of 3, and secant, yeah, it's a reciprocal, right, of the cosine value. And after rationalized rationalizing the denominator, we get this same value, but in a different form. And tangent. Tangent, so you have y over x and cotangent x over y. So they're reciprocal to each other. But the tangent, we can also rationalize. So let's see, if you rationalize this value, so you multiply both numerator and denominator by square root of 3, you can rewrite the answer as square root of 3 over 3. So that's a value after we rationalize the denominator. Okay, so we just worked on an acute angle, which is 30-degree angle, and we found all 6 trigonometric function values at this acute angle.